here with William Harvey of Power Engineers. William, you received an award from GRC the other day, the Bill Holt Award.
Ben Holt Award,
Ben
that's
Holt,
correct.
Could you tell us a little bit about the background of this award?
So, the Ben Holt story is kind of a neat one, and I'll tie in some other engineering companies from around the world. Ben Holt started a company several decades ago that was really instrumental in the United States in some of the early geothermal development. Really innovative, and I still look back at the papers they developed and the legacy of their plants and appreciate what they've done. And so the Ben Holt Award goes to people that in some fashion or with their teams have contributed to kind of the surface side, the power plant development stuff. And if you wanted to compare it to your experience, it's kind of like the old legacy of Vafkikau, predecessor of Manvilt, or SKM, now part of Jacobs, or kind of Morrison Knudsen, where a lot of our experienced engineers originally came from. And I really appreciate the award because it's part of that long legacy of kind of geothermal surface facility engineers. It's interesting to see the evolution of these different firms through the decades.
I mean, congratulations! I mean, it's an honor, I assume. So,
I cannot accept any individual awards. Right? It's always a team award. And when we introduced it, yes, I'm with Power Engineers. But to be fair, I think part of the award was that I try as much as I can to span different organizations, and so I really deeply value my affiliation with Reykjavik University and the Iceland School of Energy, and to try to blend some industrial experience and by experience designing, constructing, etc. power plants with all the students that are coming in those channels and kind of introducing them to the old geothermal heritage and the geothermal literature. So I'm kind of a hybrid. There's smarter power plant engineers in many continents and many places that have been my mentors that haven't gotten the award yet. But it's more of a metaphor or a symbol for that blending. I hope that's what the award's for. It's not my good looks.
So maybe kind of as a background, can you tell us a little bit about Power Engineers and the geothermal team of Power Engineers? You've played an important role in geothermal. I mean, you've designed, I think, more than 100 or 1,000 megawatts in geothermal. So, you have played an important role, right, as a company.
We have contributed to that. So, my involvement started over 20 years ago, and Power Engineers had some of these kind of legacy engineers from Morrison Knudsen and other people that had been in the power industry, like Kevin Wallace was in the PG&E at the Geysers and assembled these teams. And when we started doing projects as far back as before my time, but Heber in 1993, and in the Philippines, Mindanao. My first project was Miravalles Tres in Costa Rica. Great little project, loved that project. And from there, we've done EPC and then branched off to do owner's engineering, independent engineering, and things like that. But it is rewarding to really get your kind of arms into the animal and to do the entire detailed design down to the last bolts and nuts. And then it gives you appreciation for what that process is like if you step into different roles. So yeah, we've been around the world. We've worked with other colleague firms in other nations and stuff like that. And I think the collegiality of this industry is great to see. At the booth, you're talking with people that in theory might be competitors, but we're all kind of colleagues, and the real thing we're competing with is climate change, other industries and stuff like that. So I view all the people here at the conference, regardless if we're competing or not, as collaborators. Right? Yeah.
So, I mean, it's interesting. I mean, I've actually been following you like on LinkedIn and other places, and you've been let's say, outspoken about certain things, and you've just recently published a fantastic opinion piece on the fantastic GeoVision report that was published. Really interesting to read. Maybe kind of like as an explanation, the GeoVision report was a DOE report, kind of highlighting, let's say, the opportunities for geothermal in the United States and some kind of game plan forward. How important is that kind of work for geothermal?
In all fairness, I was a reviewer on the GeoVision report. So I had a little preview of what the final report was going to look like, and I provided some feedback, but all due credit to all those teams that worked on that report. And, the final report, when it came out, I looked at that and I said, and Alex, you've probably noticed this, Americans, like any nation, can be a little American-centric, but I looked at that report that was, I thought it is a very high caliber U.S. report, and I said, there are students I have and developers that I work with and other people internationally that should read this report. It's got content that's relevant, all around the globe. And so my highly derivative piece that kind of summarized some key points and a little take on it was really to encourage people to read the report and collect all their things and not think that this was a U.S.-focused document. No, it's got wide applicability. And I think we're in agreement that we can also be a little focused on electrical power production. And that GeoVision report, I can't say the first time because there have been many people talking about these for decades, obviously, but it did a good job in making the conversation richer about all the different byproducts. And so many people have been doing this. Ornstein and Thompson's 2017 paper about all the additional value that it provides is a great reference to starting to turn that ship. And that GeoVision report is another example of a better conversation about all the value that it brings, I think.
And we just sat on a panel today, the two of us, and we talked about geothermal in that context of electricity versus direct use or heating. Naturally, in the European context, we talk a lot about district heating. That concept that you have a centralized system and you transport the heat. How realistic would kind of something similar be for the US?
So, I think I'd written something ages ago, and I forget when and in what context, but I think Americans, I'm American, okay, Americans have sort of forgotten that we have a long heritage of direct use. If you look at the Boise heating system, if you look at the great things that have been done by John Lund at OIT and that campus, and even in my home state of Idaho, we have hot springs resorts all over, fantastic commercial opportunities. We grow alligators, we've got fish farms and stuff like that, but we've sort of forgotten our own legacy, whereas nations, to their credit, like Iceland, have done a fantastic job integrating that and promoting that. So it's not like it's never happened here. It's almost like we've forgotten or aren't doing it to the greater extent that we could. But to your point, how practical is that? It's very practical, as I said, like in Idaho, scattered resorts, smaller towns. The town I come from actually has a hot spring distribution system that just isn't as fully implemented as it could be in Ketchum, Idaho, because there's this resistance. So probably just like anywhere else, it's an education and it's a capacity building exercise with the local town or things like that it would take to bring that into wider applicability. There's nothing that should stop it.
Maybe back to electricity. We've in the past we've seen relatively large projects, 50 megawatts and plus. Turkey, for example, is one of the countries kind of that has, let's say, changed a little bit the game, like
yes.
with more projects or more plants, but of smaller size, and thereby maybe in a way also speeding up development. Where do you see kind of the future on the size for geothermal projects?
This is kind of funny because we might differ a little bit, but I think at the end of the day we'd sort of agree. Is if I could sing like the Empire theme from Star Wars, if you're familiar with that, the large evil empire, I do believe, as somebody that's studied these things, that pushing the boundary a little bit in a responsible, sustainable manner, the economies of scale are fairly substantial. So be it flash or be it binary, we have seen trends over the last 10 or 20 years that are pushing the binary suppliers to larger wheel sizes, larger and larger, double turbine arrangements that are up to 40. So if the resource supports it, I think going up and examining those economies of scale is a competitive advantage that we need to have. Now, and we discussed this a little bit on the panel, if the resource is limited, if you need to get a victory in that area in order to establish a proof of concept or a smaller application, if you don't need in a remote Alaskan village or something like any more capacity, then the smaller modular type units in the sub-megawatt range, or a wellhead unit to prove a new field, proof of concept for several years, that's in the 1 to 5 megawatt range, then that makes sense. But at my heart, part of me is sort of an evil empire kind of guy, because I see the influence of economies of scale.
Yeah. That's interesting. So how would you see the opportunities, for example, for like this, let's say, increasing discussion about like smaller, like even smaller units than 1 megawatt, like 100, 200 kilowatt kind of machines in a let's say decentralized way of utilizing geothermal? You mentioned Alaska and smaller communities. I mean,
China being a great example. There are great examples of small units, and then there's counter examples of small units. Okay, so what are the great examples of small units? I think China is one of the classics. I would say Osirian, or some of the other smaller wellhead units, even the ones at Kengen, the fairly large assemblages. But the counter example, I will just state as a fact that we've seen in the United States, is when you chain together 100 very small units. Historically, that has not worked out so well in the United States. So this kind of creative tension between right-sized units, but not too many of them. I don't want to take care of oil changes for 100 cars any more than I want to take care of 100 smaller units. Will that change? Would manufacturing economies of scale change the game in that fashion? They might. We haven't seen it yet. So I think the smaller units are suited for the smaller resources or exploratory things. That's what it seems like so far, looking at experience.
And maybe, there are tons of things I would love to discuss with you, because I always enjoy talking to you, but maybe as a closure, like we talked about opportunities and challenges for geothermal today, maybe briefly, kind of where do you see the key growth markets for geothermal? And now I would just refer to the electricity sector.
I would, personally, selfish, I would love to see conditions improve in Turkey, economic, social, some technical, but I would love to see conditions reemerge there, and their economy and growth rate of geothermal have a resurgence. I mean, it's such a great place to go and do work. It's got such great talent. It's got such great resources. It's got such great electrical and direct heat opportunities. That would be one of my favorite places to see more growth. But also I would say Africa, right? We have so many great successes in Kenya. Kengen, fantastic job there. We've seen the impact of baseload geothermal offsetting hydro droughts and things like that. Super high value. Now, can the surrounding countries have some similar successes? I hope so. And when they can do it and have some of those wins and then build on those, I'd love to see East Africa take off as well.
William, thanks a lot for taking the time.
Oh, well, thanks for being on that panel, and I want to say that I really appreciate the work that you and Think Geoenergy do. You may not know it, but I'm a very large promoter of Think Geoenergy. and there's a lot of value that I think people need to be steered towards in terms of reporting and good statistics and good reporting.
Appreciate it. Thank you so much.
Okay, thank you.